Medium-chain triglycerides versus long-chain fats, rapid ketosis, and visual function. Medium-chain triglycerides, MCTs, are fats with shorter carbon chains, mostly 8 to 12 carbons, like caprylic and capric acid, that are found naturally in coconut oil and breast milk. Long-chain fats, LCTs, include most other dietary fats, 14 plus carbons, such as olive or sunflower oil. The body handles them differently. MCTs go straight to the liver through the bloodstream and are rapidly turned into ketones, an alternative fuel, whereas LCTs enter via the gut's lymph system and take longer to process. In one study, giving healthy adults pure C8 MCT oil caused blood ketone levels to jump roughly 4 times higher than the same calories of coconut oil. In short, MCTs raise ketones much faster than LCTs. Ketones are molecules the liver makes from fat that many cells, including brain and retina cells, can burn for energy when glucose is low. MCTs have been studied for brain and eye health. In aging and certain eye diseases, glucose uptake can drop and cells starve for fuel. For example, low brain glucose use in Alzheimer's or aging has led researchers to try ketone supplements to bypass this energy problem. One conclusion from a clinical trial was that optimizing MCT formulas might help counteract declining brain glucose use in aging. In other words, ketones from MCT could provide extra energy when sugar isn't enough. Similarly, these extra ketones may help visual processing and cognition when given acutely. In experiments, healthy adults who drank MCT oil versus the same amount of olive oil performed better on certain mental tasks. For example, one dose of MCT improved attention and decision-making in a Stroop-type test. Working memory also improved after 4 weeks of daily MCT compared to long-chain oil. These findings suggest that MCT-derived ketones can give the brain and eyes an energy boost, potentially speeding up cognitive visual tasks. Importantly, glaucoma, a common disease of the optic nerve, involves energy failure in the retinal ganglion cells, RGCs, that carry vision signals. Research shows glaucoma is tied to metabolic and mitochondrial dysfunction. RGCs are very active nerve cells with many mitochondria located near the optic nerve head. They rely heavily on oxygen-based metabolism for ATP energy, so if mitochondria struggle, as can happen in glaucoma, RGCs get damaged. Because ketones can feed mitochondria, scientists are exploring if a ketogenic approach can help. Animal studies support this idea. In a mouse model of chronic glaucoma, feeding an 8-week ketogenic, very low-carb, high-fat diet protected the RGCs and their axons. The ketogenic mice had more retinal mitochondria and better energy status, and far fewer RGCs died, compared to control mice on a regular diet. That study actually showed ketogenic diet generated mitochondria, improved energy availability, and protected RGCs in the optic nerve. Another recent glaucoma study found that ketones helped clear out damaged mitochondria via mitophagy in RGCs under stress, further protecting these cells. How might ketones reach the nerves? In the optic nerve head, astrocytes, support cells, wrap around RGC axons and shuttle energy. Brain research shows astrocytes can both produce and export ketone bodies, and they have transporters, MCT1, 2, to send ketones to neurons. This implies that if blood ketones rise from MCT intake, astrocytes could use and deliver that fuel to RGCs as well. In practical terms, clinical trials could measure these effects. For example, a crossover feeding study could give glaucoma patients a meal containing MCT oil on one day and a similar meal of LCT oil on another day. Each person tries both. Researchers would draw blood every 30 to 60 minutes to chart the ketone rise. At the same time, patients could perform visual and cognitive tests. Tasks might include contrast sensitivity, reading faint gray letters on a chart, and other visual processing drills. Contrast sensitivity is the ability to see objects that don't stand out well from the background, and it often worsens in glaucoma. Meanwhile, a pattern electroretinogram, PERG test, could be done to directly measure retinal function. In a PERG, electrodes on the eyes record the retina's electrical response to a changing checkerboard pattern. If ketones help retinal cells, one would expect that after the MCT meal, when ketones peak, patients might detect low-contrast images better or show stronger PERG signals than after the LCT meal. To our knowledge, no published study has done exactly this yet, but animal results like those above give the idea that ketogenic fuels may boost retinal health. Safety and tolerability are key too. MCTs are generally safe, but can cause digestive upset. Many people experience stomach discomfort, nausea, or diarrhea if they take too much too fast. In one trial, people on an MCT regimen reported more abdominal pain than those on an LCT oil, sunflower oil, regimen. That same study showed MCT clearly raised blood ketones more than LCT did, but the trade-off was mild GI discomfort. To improve tolerability, investigators have used emulsified MCT formulas, mixed in milk or protein, or start with low doses and gradually increase. In fact, emulsified MCT preparations raised ketones even more and cut side effects roughly in half compared to plain MCT. With careful dosing, many adults tolerate up to 30 gobs per day of MCT with minimal issues. Conventional LCTs, like olive oil, usually cause no acute GI side effects, so one might alternate or limit high MCT doses as needed. Another safety question is blood lipids. Since MCT oil is a saturated fat, does it raise cholesterol? Recent reviews suggest pure MCT oil has a small impact on blood lipids. For example, a systematic review found that replacing other fats with MCT oil did not significantly change total or bad LDL cholesterol, although triglycerides rose modestly. In contrast, coconut oil, which contains some long saturated chains, tends to raise LDL more when compared with unsaturated fats. Thus far, studies indicate moderate MCT use, core 30 grams per day, is unlikely to spike LDL significantly. Of course, people with cholesterol concerns should monitor levels under medical guidance. In summary, MCTs enter the liver quickly and generate ketones much faster than ordinary long-chain fats. This rapid ketosis could help feed stressed nerve and brain cells, a tantalizing idea for conditions like glaucoma, where retinal cells suffer energy shortage. Preliminary animal data show ketones preserve retinal structure and function, and human crossover study designs, measuring ketones, visual performance, PERG, etc., could test whether an MCT boost acutely sharpens vision tasks in glaucoma patients. So far, moderate MCT intake appears relatively safe. It doesn't markedly worsen LDL cholesterol, though it can cause GI upset if overdone. Patients should start MCT slowly and watch their tolerance. Overall, replacing some LCT with MCT is well worth studying for its potential vision and cognitive benefits, as long as doctors and patients keep an eye on side effects and lipid profiles. Source 2, Source 3, Source 4, 5, Source 6, Source 7, Source 8. All links to sources are available in the text version of this article. You can find the full article at visualfieldtest.com. Thanks for listening. To check your visual field, click the link at the bottom of this article or visit visualfieldtest.com.